Welcome back to the VeraGrid Feature Spotlight series. In our last episodes, we explored how to model a network and solve the power flow and OPF under normal operating conditions. Today, we take the next step in the workflow. Now that we understand the base case, we turn our attention to what happens when something unexpected happens in the grid. That's the purpose of contingency analysis. Instead of simulating only the intact network, we test credible outages like losing a line, a transformer, or a generator, and check whether the system remains secure. Most studies focus on N-1 security, meaning the grid should stay within limits after any single component outage. In practice, we look for issues like thermal overloads or voltage and angle violations. In VeraGrid, we group these contingency events in groups so you can run as many concurrent events as you want. In addition, you can run contingency studies with two complementary methods. The first is the power flow-based method, where VeraGrid solves a power flow for each outage. This is the go-to option when you need detailed results and want to capture voltage and reactive power effects properly. The second is the linear method, which uses a DC or sensitivity-based approach to estimate post-contingency flows. Being faster, this method is ideal for rapid screening and ranking, especially when you have a large contingency set and want to identify the most crucial cases before running the full AC analysis. An important point to note is that due to theory on linear analysis, a maximum of 2 contingencies can be studied at the same time. Now, let us move to a practical demonstration inside VeraGrid and see how these methods work. We begin by loading the same IEEE 14 grid that we used in earlier episodes. Once the model is open, we can run the base case power flow, and then we can start defining the contingencies. As we mentioned, in VeraGrid, contingencies are organized in groups. Each group represents a scenario, and each scenario may contain one or several events. For example, you can create a simple case where a single line disconnects, or a combined event where 2 lines trip together. To do this, we'll select a single line on the schematic. If we go up to the top, we can add this line as a selected contingency. We can also do this with multiple lines, for example, selecting these 2 lines and adding them as well. Now, if we go to our database, we can see that both of these contingency groups have been added, both one with a single contingency and one with multiple, and all of our defined contingencies also appear here. Now, in practice, it's very impractical to define all of these contingencies manually. So one thing that VeraGrid has set up for you is the ability to initialize all of these contingencies automatically. For example, in this case, we'll look at initializing all of the line and transformer contingencies to the N-1 case. But it's important to note that we can also add contingencies for injections, such as generators or batteries, and also other branch elements as well. We can also filter the contingencies by voltage for the branches and by power for the injections. So let's go ahead and generate our N-1 contingencies. If we go back to the database, we can see that all of our contingency groups are now defined, and we can see that they're all single contingencies as we're defining the N-1 case. Now that we've correctly defined the database, let's take a look at the settings. You can select between the 2 primary methods that we outlined earlier, either the linear mode or the power flow mode. Additionally, you can activate scrap, a mechanism that will adjust the generation if a contingency is identified to see if the contingency violation can be cleared. You can also apply a deadband to the report, such that only contingencies with a notable effect from the base case will appear. Now that everything is set up, let's run the contingencies. First, we'll run based on the existing dispatch present in the model. As we can see when we check the branch loading in the results, we can see that some of the branches are overloaded. One thing that we can do to rectify this is to use the OPF as the base dispatch for this simulation. So if we go back to our settings and make sure that we're running our linear OPF with contingencies, we can run that simulation, And simply by clicking on the button beside the OPF simulation button, we can use these results in our contingency analysis. As we see on a first view of the grid, our results have improved a lot. And if we go more deeply into the branch loading that comes out, we can then see that none of our branches are now overloaded. Alternatively, you can create yourself a script that will define these contingencies, giving you more control over the process. Let's take a look at a couple scripts that we've developed. In this first script, we run through all of the branch elements, notably lines and transformers in this grid, and create a contingency associated to a contingency group in this case. But we can also call our contingency wizard directly from the code. In this case, we're running exactly what we've done manually through the GUI, creating for all of the branches in the model, the n-1 contingencies associated with this model. Once we've defined our contingencies, we can simply run the OPF and then run both the linear and nonlinear power flow using the base OPF as dispatch, and also the linear and nonlinear contingency analysis. If we run this script, we can see the comparison between both of the methods. As we can see, both for the linear power flow and the nonlinear power flow, along with the nonlinear and linear contingency, we can see slight deviations in the branch loading. And for the nonlinear contingency, we can see deviations between the base power flow and also the contingency analysis. That wraps up this feature spotlight. If you have any questions or run into something you'd like clarified, feel free to leave a comment below, check out our documentation, or reach out to us directly on Discord. We're always happy to help. We'd also love to see what you build with VeraGrid, so don't hesitate to share your projects or results with us through the contact links in the description. And finally, if there's a feature you'd like to see added, consider contributing to the project. Your ideas and feedback play a big role in shaping the future of VeraGrid. Thanks for watching, and see you in the next video.